Alright, greetings. Welcome to the dojo. Dark Mage in the house with the sick flow. You already know about that code I already wrote a long time ago. When I was stoned in my home tetragrammaton. Cranking up the mic so you can hear my volume though. Alright. What's good, everybody? How y'all doing? Y'all ready? What have I done so far? Not much yet. We got this make file I just whipped up, but it doesn't make tests correctly. So we're gonna have to tweak that up a bit. I feel like listening to some doom metal while I do this, so I'm not gonna be talking a whole lot. I got this fucked up tooth. It's been clawing at my tongue. So I have to be extra careful. I'm also looking to get into the zone right now, so I'm probably not gonna be doing a whole lot of explanation on the things that I'm working on today. So if you want to, just sit back, relax, grab a cup of coffee, grab your bong, get your laptop, start working on whatever projects you want to work on. Do so alongside with me. I think that'd be pretty gravy. Y'all like doom metal? I like doom metal. So I guess you don't have much of a choice. We crank the volume down a little bit. Maybe not. Maybe I'll just mute myself. I don't know. What y'all want? What y'all want to do? What y'all got going on this Saturday? Hit me up in the chat while I'm working. Try to distract me. All right. I won't be responding with my voice, but I will be reading. So if you got anything to say, hit me up in the chat. Otherwise, let's come back to it. Make files. for a little bit anyway. Do we want the camera on? I feel like I need to chat about what I just did and what still needs to be done, why I need to do it, why this is all important, why have I done this to myself? Okay. So it's a weird situation, all right? How do I begin? Okay, we'll begin this way. So my dungeon, right? Dungeon floor, dungeon tile. So I've restructured like the core layout for how dungeons work in my game recently as a step towards trying to optimize frame rate, because for some reason I think I figured it out and I might not have needed to undo as much stuff as I actually did, but it is what it is. In the quest of 60 FPS, which is like, it's a 2D game, why the fuck would it be slowing down unless there was some crazy caching or optimization issue going on? And I figured out what the problem was, and it was a pathfinding algorithm that was doing some additional shading that probably could be omitted for this game, right? So I got rid of that, and now I'm putting back together things that previously did work. Originally, things like cached live NPC, cached item, cached box, cached door. Originally, we were just maintaining like a raw list of entities on each tile, and this was expensive. Like it, or at least like I thought it might have been expensive, and so I undid it, and now everything is just like an integer. But realistically, I just had to thought, fuck, we might need more than one dead NPC on a tile. Like, you know, like in old video games, like when, due to resource limits, a sprite, you know, like gets you kill an enemy on the screen and it flashes and then it disappears out of existence and it's no longer rendered or even managed by the system. Well, I'm like, it's 2026. We should be able to manage this many entities, right? Like, we should be able to manage like having lots of dead bodies on the screen and like not cleaning them up or anything like this. Ideally, you know, the state of the world persists like a blockchain. And that said, it's like for every change to the world that exists, it grows. But if there's a way to like kind of collapse those old histories, and sometimes are they even necessary, into a singular state, then we could probably eliminate some redundant data storage. But we're not anywhere near close to talking about that yet. So I originally thought, wouldn't it be nice to have more than one dead NPC? So like if you kill an enemy and then an enemy stands on top of the dead enemy and then you kill the second enemy, there are now two dead enemies on that tile, right? Logically. Well, under this system where, or the old system where, is an intermediary step between migrating off of like arbitrarily sized vectors that might contain all of the items, all of the other things, you know. But I also thought, realistically, there should only ever be one living NPC per tile. And so there would never be, like, because like in Dwarf Fortress, you can have more than one living NPC on a tile. And so this is one way that my game differs from Dwarf Fortress in this way, is that sure, you can have more than one dead body on a tile, but there's only ever going to be one living NPC at most. in any one XYZ location. This is a really important point to me because it makes management easier. It makes logic and presentation a lot easier and a lot more makes sense. You know, you don't have to like mouse over the tile in order to like get the current state of like what the game is. You can just look. You know, it's just like obvious. Anyway, so that's like a logical consistency thing with me, is like, as part of making the superior game, or making a game that I feel is superior or is worthy of coming into existence, little things like this kind of come out. So the point being, I want more than one dead body per tile. And so to solve this problem, I've created very simple static memory storage. It has a finite limit that can be tuned, and we can figure out what's like optimal, you know, how many, like what's the most realistic that we should store. Because let's say we do 8, right, and you kill 8 enemies on the same tile, and so now you've got 8 dead bodies. What happens to the 9th one, right? Like, realistically speaking, you can't have infinite dead bodies. It's just not practical. So what happens when you get to that point where you have too many dead bodies and you have to figure out what do you do with that next one, or the oldest one, right? You got to rotate them. So the oldest one goes out, everything shifts down by 1, and then you put the new one on top. So it's a rotating stack. So I just had the thought, fuck, we're gonna have to do this for items as well, because realistically speaking, you could have more than one item on a tile, and at a certain point I'm gonna have to create mechanisms that allow you to select which item that you actually want to pick up, rather than just like operating in the same stack way. Because realistically, dead bodies might be stacked on top of each other, but items themselves, like if you have 10 dead bodies on a tile, items are going to be immediately accessible. So like you stand on that tile because you want to pick up like the knife +5 that's sitting there alongside like 10 other enemies that you just killed. So you walk on top of that tile and you hit the grab button. Now let's say there's another item also on that tile, like shield. I've not yet gotten to this point, but I'm reasoning through how this would work, or how I would want it to work. Like, what's the most natural feeling experience of picking up an item that's sitting on top of a bunch of dead bodies? I mean, you press the pick up item button and a menu appears. And so there would be a limit to how many items you could potentially store on a single tile as well. And so you have to handle these situations where, what happens if we add yet another item to a tile that can hold 8 items? So with dead bodies, we rotate, right? But we don't want to rotate with items. We want to do something different. With items, we would want to perhaps, using like the Sheeran, the Wanderer mechanism, where Sheeran only allows 1 item per tile, but if a second item drops on top of that item, the new item would bounce to a random tile around that tile. And if one of those tiles is all filled up, or if it can't find an open free tile, then it picks one of those tiles at random and then repeats the process kind of recursively. Now it'd be kind of fun to see what happens in that game if you like put an item down on like every single tile in the dungeon and then, you know, try to like do something. That would be kind of weird and interesting, but it would also be very hard to do. And so they probably thought, okay, well, this is probably good enough. And similarly with my game, I'm going to have to at a certain point say, okay, this design is good enough. You can't be perfect with everything, and sometimes a problem only has to solve or be solved to a certain point. Like, you don't have to necessarily encompass the entire problem like input space, right? It's one of the, I guess, failings of simulations in games in general, is that you can't account for everything. And oftentimes the things that we experience are at best really good approximations. And so, you know, creating like an immersive experience isn't necessarily about perfecting the realistic real world simulation of, like, say, holding a gun and firing it, you know, as like a first person shooter. It's not always the most realistic things that are the most fun. This is a common talking point in game design and like things like this. Here, I'm reading chat now. I still use my own minimalist agent I wrote sometimes, but for big stuff, Claude code is amazing. Easy to build onto, can write Lisp. Nice. Ada was great, but I feel like started lagging behind the newer agents. Claude seems to be able to build plans and then follow them better. Just in my opinion, the planning feature is really good. Yeah, I've been meaning to actually try and integrate something like this into my own workflow. A plan. Multiple people on one tile also made the game just messy looking. Yeah, exactly. The whole idea is that, like, the more, like, it's already to a point where, like, there's so many different things that have to be managed. And so anything I can do to kind of limit that going forward while also still being flexible enough to achieve the designs that I want. And so long as it doesn't, like, create a performance hit, then we're going to just keep going with that design. You know, fuck it. So there were a couple other small bugs that I noticed too. I think one might be related to visibility. Ultimately, I'm not sure that I need a visibility parameter or like a component, because light radius effectively handles that, right? Like at the same time, because like the whole thing with light radius is that you can walk places in the dungeon and then walk away from those places, and by the shading, you know, by the lack of light on the tile, kind of indicates like a little bit of a fog of war effect. And so you kind of have this indication that, oh, I've been here. I can't see what's currently there, but I know that I've been there. So this allows for, you know, you to have the entire map for your current floor rendered all at the same time. And so in the best case, you have a very big map, right? So like, what would a big map look like? Let's talk about that for a minute. Okay, so in dungeon, so the way we're doing this at the moment, it's in dungeon floor. You just change the definition of dungeon floor width and dungeon floor height. 256 by 256 currently feels like the best. Like you still get performance while also enjoying a big dungeon. It is a very big space, so like we're fully zoomed out. And actually, because I don't want to do this manually, Look, Ma, no hands. Okay, so this is fully zoomed out. As you can see, we are running at full 60 FPS. Average draw frame time of about 16.57 milliseconds. You know, 256 by 256 is not a small number in the grand scheme of things, right? Especially when you consider like what is actually being stored in each one of those locations. 65,536 tiles. Each one of those tiles, every single one of those tiles is composed of this. Every single one of those 65,000 tiles has 5 Boolean variables, an integer tile type, 4 entity IDs, and a dead NPC cache, which is itself composed of a long integer count. His size t is effectively you can effectively think of it like a long integer, like an unsigned long int. Followed by a series of about 8 numbers representing integer IDs or entity IDs. So that, right, oops, times 65,000. And we're probably going to shake that definition up a little bit. The reason being, as I was saying before, I want multiple items on each tile. There will only ever be one box. There will only ever be one door. There will only ever be one living NPC, and not necessarily a combination of all 3 of those at the same time. Maybe you can push boxes through doors. That probably makes sense. Of course, NPCs can walk through doors as well. And items can also go through doors. But if there's a door that's open and you put an item in that doorway, then you can't close the door until you pick up and remove the item. So there's like a lot of logical rules to the way that like things interact with that has to be consistent in order for it to make sense. I've thought about this stuff. This is stuff that I've experientially learned along the way in implementing it to this point. Notice we've been walking around for a hot minute and we haven't hit the edge, right? Now, unfortunately, I don't have a way to like override the automatic playthrough, right? So one thing that we can do is oh wait, I gotta do that without the test variable. Hold on. Okay, let's kind of map out how big this is, right? Point being, you could walk around in this place for a while. If, like, you actually carefully craft every single, you know, inch of this dungeon, lack of a better word. Yeah, it's like, how big is this space? You know, designing even like, you know, one of the benefits of small areas and minimalism is that it kind of restricts possibilities. So if you kind of suffer from decision paralysis, like I do very frequently, it ends up being a very convenient tool as a artist and creator in order to like make better decisions and actually just kind of get something out there, right? Because it's better to get things out there than not get things out there. Sometimes people might say it's better to spend more time doing a thing, but I also think that it's very important to document the process from start to finish. As you can see, 256 is huge. There's a lot going on in here. And one of my curiosities is, how much stuff can we have going on such that like we're able to still maintain 60 frames per second while also still having an area of this size and scale? And it's probably going to be a balance between number of tiles per dungeon floor and number of entities that we actively have to process on a per like time step basis. That's what my gut's telling me, and it'll be interesting to kind of push those upper bounds, right? So one thing that we could do to do that before I have to get ready to go is when we initialize the dungeon, when we go to create enemies, what do you think the upper limit to how many enemies we can actually have in a 256 by 256 space? Well, obviously we would want to find some limitation to like bind this by. 65,000 tiles is a lot. Like, do we really want to try 65,000 right now? This is insanity. Okay, fuck it. Naturally, it's going to take a while because of the way that like the randomization placement algorithm works. There's a lot of like checking to see if there's available space, and it might be taking a while to actually place those. So I'm just curious. Let's kind of like observe. When does the slowdown occur? Like literally placing 65,000 monsters. Let me check the chat in the meantime. 60, so we're getting up to, we're able to get up to 15. It still took a while, right? Like to get to 15K. Like, so like even like I wouldn't want this like lag in the startup at all. This is crazy. Realistically, like I should be able to play 65,000 monsters a lot faster than this. But it's the way that I'm doing it that is realistically like the cause of the slowdown. The code obviously runs. It's that my logic does not scale to this kind of value, right? Like I was doing a very naive placement where I'm just randomly selecting positions, and as a result you can see it's taking us fucking forever to like actually place all of these. but it looks like it's still placing them all in linear time, and that there's not necessarily a strict slowdown that way, but it is taking a long time. This was interesting. I'm glad that I chose to do this. Got a little bit done with the code base. Moved things forward. Hadn't touched it in a little while because I've been focused on not hacking. Almost there. That's gonna be crazy. I can't wait to see what the frame rate is. Finally, god damn. Holy shit, look at this. Catastrophic. Oof. Catastrophic slowdown. It's slowed down. It hasn't even... Jesus. Holy god. Amazing. Like, there's input lag. Oh, shit. This is great. Okay, we have a lot to optimize here, obviously. Where is my debug panel? Holy God. I can feel my game struggling under the weight of what I've thrown at it. Oh, Jesus. Okay, so maybe we should probably start the test at a bit smaller of a number. Right? Maybe instead of 65,000, let's start with like 1,000. Oops. Okay, 1,000's fine. What about 10,000? Maybe we don't want to print it out right now because a lot of people don't know that I/O is like incredibly slow. Like you want to make your program faster, get rid of all output. Because it's already going to be like any bottlenecks you have are already going to be slow, and things like repeated printing, as much as they can be useful. So it took a minute to like put down 10k enemies, and we get lag. Oh, we get lag. We get super lag. The game's not so slow that it's like dying, but it is a wonderfully slow 17 frames per second with 10,000 enemies in a 256 by 256 space. So 256 by 256, right? Like if we take 128 times 128, that's 16,000, right? So what if we were to cut the size of the dungeon floor in half? It's still going to take a while to place down 10k enemies. Yeah, it didn't take as long. Okay, interesting. We are still experiencing slowdown. Pretty significant. So changing the size of the dungeon floor did not impact that calculation. It did impact how quickly I was able to place them down, though. which is, it's really interesting how that kind of works. And yeah, movement, oh man, it's so slow. It's so slow. Oh, this hurts my soul. Oh, this is so bad. It's still functioning, and input's actually responsive when I do get to input. Actually, I mean, input's really responsive considering. I find that interesting. But just rendering, oh man, it's just choking. So what about half of that? We're looking for a sweet spot here. Like, we want big dungeons. Okay, so 5,000. Um, 30 frames per, so it's a little bit faster. 5,000 is still not that much, but I mean 2,000, let's try that. In Dwarf Fortress, I believe the size of an area is 256 by 256 as well. But probably one of the reasons that they decided not to have like full animations like that was performance reasons too. Okay, 2,000. Okay, 2,000's where it's at apparently. So we can find the edge. Okay, so there's one edge. We want to find the bottom. There's the bottom. Oh yeah, so taking a look at the average draw time's really fast actually. Like, we are getting a very good frame rate performance. Yeah, I remember that this game is entirely single core. I'm using no threading or anything like this. Like, it's kind of like, how much stuff can one CPU core handle type situation, you know? And this is not bad. You know, like I know in memory it's not using a whole lot. Okay, so there's the edge. All right, let's zoom out. Right, we get a full view. Oh, and even then, okay, yeah. So this is a 128 by 128. So I think I think this is sufficient. You know, from a big maps perspective, I think this is a good balance. Like, if the game can be this performant with this much stuff going on in it on a turn-by-turn basis, like, I'd say that's a win. So when we go to create orc, and then we go to create orc, and then we go to create NPC, we go to set defaults. And in set defaults, we have a default action. And we can change that default action to move randomly. We could even mess around and try some other stuff some other time. I gotta get ready for a meeting real soon. Let's see what random movement looks like for 2,000 entities in a 128 by 128 area. I mean, there might be optimizations that can be done to push these limits, but at a certain point, there are like physical limits to this kind of thing. And we might be able to overcome some of these limits through, you know, very clever optimizations. But for design purposes, I think this is a good starting point. Now, naturally, rendering will probably slow down the bigger your light radius is. What if you had a very big light radius? So the frame rate's not real. Oh, okay, no. It's definitely slowing down now. And there's reasons for this, because of the way that things are handled. In a similar way that I got rid of, and actually I see like some disappearing action with the drawing going on too, so there's definitely a lot that I gotta look at. But today was not a bad day for productivity, just for getting started again. So I definitely have some stuff to look at. I'm going to leave these variables in place and leave the game in this current state to remind myself that I have some, I have to examine the current rendering loop, because I'm pretty sure that's where this slowdown is actually coming from. It's probably not some other places, but with these variables, I'll be able to also create flame graphs again and use those as a kind of a guidepost for what I need to take a look at and possibly eliminate or rewrite. All right, kids. Anybody have any questions? I am using GPU rendering. Everything I do is actually with textures, which in Raylib terms, you have two primary like image objects. One's actually called an image, but it's CPU based, and texture, which is GPU based. So the rendering logic has to do with the gameplay logic as well. So there's a lot of potential spaces. I gotta get more coffee too, y'all. But I will likely be back on later to continue this process. So if y'all give me, let's see, my meeting's at like 1, so if I do 1 to 2 and then eat some lunch or something like that, and then maybe get back on like around 3-ish, 3 or 4-ish. Just kind of continue hashing out this stuff. Well, no, we don't want to load what's in the visible area, because, like, I mean, it's kind of what I'm doing with the light radius situation, but there's some other thing in there that's possibly slowing it down. I'll have to take a look at. We'll be able to examine this more in depth when I come back. I'll show y'all flame graphs and like how to actually use and generate those to kind of isolate things, because we'll probably need to do that anyway. It usually helps make it faster, kind of like identifying things, but I play lots of games. I don't get necessarily as many viewers, although I did get a lot of people who watch me play Skyrim. There's a lot of games I gotta get back to. You know, there's only so much time in the day. So, you know, it's like, do you choose to spend your days not making your own thing? Or do you make your own thing and then sometimes take breaks and play some other people's things and, you know, kind of participate in this back and forth dynamic that is the wonder of the game industry. An industry I was born into, ish. But anyway, I gotta go. Love you guys. Catch y'all soon.